data parallelism is something that has been much more explored as a concept. And basically, a simple version of a data parallel network is one where every miner on the network has a full copy of the model. So they have all of the layers. Again, per Felix's point, that's more expensive for a large model. They have to run really powerful hardware to be able to process so many layers of the model. But what happens is, if all of those copies of the model are training on just different shuffles of this big book, and then occasionally they will share their information and synchronize so they benefit from the learning of the entire group, that's what data parallelism is. And we actually use that as well. So we basically chop this large model up into sequences or sections, which we call the layers. But each layer, we actually have 50 workers in each layer as well. So it's called data parallel and pipeline parallelism, which allows us to kind of get the best of both worlds. The barrier to entry in terms of cost and complexity remains low because we break the model into small chunks, but we also get the accelerated learning process that comes with having a group of people all processing different pages of the book or different sentences of the book in sort of synchronization.
Maybe just to add to this, like, the really easy way to think about this is data parallelism means you're chopping your data set into multiple small pieces, and each miner gets a small piece of the data set. And pipeline parallelism means you chop the model, so the actual compute that needs to happen, up into lots of small pieces, and each miner takes a small piece. And if you look at some of the other subnets or a lot of the other projects out there, data parallelism, what people usually refer to when they talk about federated learning, where it's like each miner sees like a small subset of the data set, so a small chunk. And what we're introducing with IOTA, I think for the first time, is pipeline parallelism, where not only do we chop up the data set, but we also chop up the model.
When you say introducing for the first time, this means the first time, like, ever that you're aware of someone implementing this? Or first time in a decentralized setting?
The pipeline parallelism is used a lot in data centers. It's the only way you can train a GPT-4. You can't do it on a single, it doesn't matter how powerful the GPU is. These models are way too big. So pipeline parallelism is very well established in the context of centralized training runs. By centralized, we mean sort of geolocated in the same data center. They have the benefit of being connected by very high bandwidth, basically networking cables, NV links or something like that. Doing it in a fully decentralized setting means you replace those high bandwidth interconnects with the internet. So you're just sending things over the wire, which presents a very big challenge because you're sending a tremendous amount of data across the world, which is of course very complex and also very expensive and slow, which is one of the primary challenges for the architecture. In terms of where else this has been done, to our knowledge, no one has done a pipeline parallel decentralized training run in history. So this is actually a world first.